That is surface and groundwater hydrology. In this module 1, today we'll discuss about what do mean by zone of aeration and zone of saturation in this topic, and what do mean by groundwater hydrology we will discuss it, and what do mean by groundwater everything we'll discuss it. And today we'll discuss about what mean forms of surface water. So in this saturated zone is there and aeration zone is there. That kind of two zone is there. So saturated zone means the in here the water table is dividing in two types. One is zone of saturation and zone of aeration. When the air voids, it means when the two soil rock placing in between, that some voids will create that voids we are calling it as odorous water. So in between that, in that water voids, the water is filling, that is called odorous water. In between the soil rock the voids is creating, that is called odorous water. And zone of aeration means in that voids it totally filled with air, that is called zone of aeration. If it is the voids is filled with water, that is called zone of saturation. So that kind of two ways we are divided. Saturated zone, this zone is also known as groundwater zone, in which all the pores of the soil are filled with water. The water table forms the upper limit and marks the free surface. So this is called saturated zone. So zone of aeration means the total air voids is the voids is filled with air, that is called zone of aeration. So this is the one diagram of related to zone of aeration and zone of saturation. Because of this attraction between the soil and rock surface as well as water, so water which is not moving, water is held in between that rocks. We can call it as, in that time what will capillary rise will create, and we are having that expression 2 delta divided by into cos theta divided by r into specific weight of water, specific gravity of water. So that we can is 2 into alpha, we can take surface tension. So alpha and divided by, as I told, 2 into alpha divided by gamma into surface weight. So before going to that, the odorous water, what we can in zone of aeration, what we can say, that is water is totally water held by we can say that is hygroscopic and capillary action. Odorous water means water held by hygroscopic and capillary action. So in zone of aeration we divide by soil water and intermediate water zone and capillary zone. And below that one water table we can zone of saturation, that above the groundwater table we can consider as zone of aeration, and below the zone of saturation. So below the ground, that we are having zone of aeration and zone of saturation. So in that zone of saturation, water is held by gravitational action, and in above the water table, what in zone of aeration, water held by hygroscopic or capillary action. So that is you should remember zone of saturation, zone of aeration. So as I told before, hygroscopic water zone of aeration and capillary zone of saturation. So capillary rise we having the formula 2 gamma divided by capillary rise into specific weight of water. So that is the general equation. And when we say we know that last class in hydrology also we discussed about that one. When water touches the surface, the water filling or water infiltrating into the soil, that is called infiltration. It means water entering into the soil, that is called infiltration. You know that one. Then after that here the groundwater table is there. Below the groundwater table as zone of saturation is there. Above the groundwater zone of saturation is there. So in between that one aquifer they are placing, that is perched water table. It means below that water table total impermeable is there. Above the water table permeable layer is there. So that is called perched water table. So So I said no, that one I last we discussed about zone of saturation. Capillary action will takes place. The water will capillary that it moves because of surface tension of the above the surface of the water. So that some capillary action takes place. So because of that reasons capillary fringe will generate. So capillary fringe will generate because of the surface tension and capillary rise of water. So that means. This is a general discussion of zone of aeration and zone of saturation discussion. So we know that as we have the formula for that one, zone of saturation and zone of aeration. And for grain size we can say grain size and capillary rise, if we can discuss about that one. Capillary rise generally in unit is in centimeter. So on which grain size what is the capillary rise? So as we told, in that saturated zones capillary rise takes place. So for the fine gravel 2 to 5 mm grain size, if it is grain size to fine gravel we can say that 2 to 5 mm. In that capillary rise is 2.5 centimeter. Very coarse sand, if its grain size is 1 or 2, then its capillary action is 6.2. And coarse side coarse sand, if it is grain size is 0.5 to 1, then is capillary rise will increase, that is we can say that is 13.5. so this totally depends on size. So then medium sand what will happen, and if generally we know that as the grain size is medium sand is 0.2 to 0.5, so in that generally it will increase, again that increase 24.5 centimeter it will increase capillary rise. You know that one, as I discussed, the fine gravel it is a low capillary rise, and very coarse sand that is capillary rise is medium capillary rise, and coarse side is more capillary rise, and medium side is again that is more 24.6, and fine side is 0.5 to point, and capillary rise for that 42.8 capillary rise for that fine sand. So this is the. And silt, if it is silt content having, what is the correct? It is generally it will increase related to that one material. It means fine gravel is less capillary rise, and very coarse sand it's medium what we can capillary rise, and coarse sand it is capillary rise will increase 13.5 centimeter will increase, and if medium sand again it's 24.6 will increase, fine sand it's more 42.8 will increase, and silt again that will 105.5, and fine silt is capillary rise is as high as 200 centimeter. You can imagine how that capillary rise will occur for different materials, and also depends on the grain size, and so materials get finer and finer in terms of grain size, so that capillary rise will increases. Do you know, the materials get finer and finer, the capillary rise will increase. So that is the general relation between the grain size and material and gravity capillary rise. So this is the one concept related to grain size and how it is a capillary rise will increase. So as we know that one, we can decide distribution of water in the course, and that also we can discuss here. So we can say that one. So the distribution of coarse sand, we can say the soil moisture content and what weight above the weight. In the related to that, we can plot the graph distribution of coarse sand. So we can say that hygroscopic component and moisture content held by capillary action. So in that, therefore, we can draw the plot related to the intermediate zone. Entirely water is held by intermediate zone, water is held by that, we can say then zone of aeration, the intermediate zone will comes in this water is held by hygroscopic pressure, that is hygroscopic action, and zone of saturation the capillary fringe will occurs in the zone of, in the capillary zone water held by hygroscopic action in zone of aeration, and zone of saturation water is held by hygroscopic and capillary action. This is in zone of aeration. So this is a one small point related to the zone of aeration. And how it is varies. Water is zone of aeration and zone of aeration. When the water table, you just check the water table level. So almost all the pores filled with the moistures, soil moistures, and then as go higher and higher, then those pores which are continuous, they are filled with water, and as we reach the intermediate zone, so it is only the hygroscopic water, which is water held by force of attraction between the spaces, between the white spaces, as well as the air, soil, or rock particles. That is so this is how we can divide the zone of aeration and the zone of saturation. Zone of saturation, the entire water is held by gravity, and that is all the water is below the ground water table, and go above at the water table, so that is water is held by hygroscopic as well as capillary action, and that reach the intermediate zone, number of pores which contain soil moisture, and only those who continuous pores. First of all, capillary action must have very small size, and then through which the capillary rise takes place due to the force of attraction, soil or rock particles, and then water due to surface tension force, and above that intermediate zone, entirely by intermolecular attraction between the soil moisture, aeroids, as well as the soil particles. And now let us consider, we can say that one. Before going to that, this water contains water held by various actions: hygroscopic action, intermediate vadose zone, hygroscopy as well as capillary action, and capillary zone, both zone of aeration, and further below zone of saturation by gravitational action, gravitational acceleration. So this moisture can be measured by various methods, gravimetric method, tensiometer, and so on. Then same thing here we can mention by tensiometer. Basically just pulls this water which is held in the ground, below the groundwater. So we can discuss measurement of soil moisture. We'll discuss measurement of soil moisture. This one will discuss gravity. Here we can measure the soil moisture. We don't know how to measure the soil moisture. For that two method is there. One is gravimetric method, and which takes the weight measurement. Gravimetric method, we can say that in that weight measurement is there, and it also by one more method is there, that we can say tensiometer method. TENSIOMETR method. In this tensiometer method, we can suppose one soil column is there. So in between that middle or any point in that soil shaft, and for that we can connect one a small tube, or that we can call it tensiometer. Then how we can measure that tensiometer or measure soil moisture, we said that for that we connected one porous cup, and we can say that is this is only using for unsaturated soil. So we can say that one soil moisture, using this method techniques, we can find it out, soil moisture. So in there, in one suction head also there, same like manometer what we are using in EH laboratory, same like this is the one of the method. So this is also one of the techniques. And section head we will get. So the water what mean entering to that one, the air particle, solid particle, we can measure what is the difference changes. And let us water available moisture content, that we will discuss that chapter. So we can available water content, available moisture content. What is available moisture or available the moisture content? So there, I said the zone of aeration and zone of saturation we will discuss. Suppose we represent soil moisture and y-axis we can represent soil moisture, and x-axis we can write it 0. So that maximum soil moisture content, y-axis, and soil moisture content, which is we can say that which is possible, is denoted by field capacity. Moisture content can be represented by MC. This is the field capacity moisture content. We can say that the field capacity, essentially the maximum possible water which can be held in the zone of aeration, and also the minimum amount of soil moisture corresponding to we can say permanent wilting point, that is minimum water usage from the soil, that is called minimum water permanent wilting point. Of course, that is also intermediate point is there in between that, about the field capacity point and permanent wilting point, that is called optimum moisture content. It is called optimum moisture content. So we'll discuss